complex conjugate of f of x. Complex conjugate of f of x. F of x equal to f bar of x. This is complex conjugate of f of x. So definition. 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 A commutative complex Banach algebra X. A commutative uh, a commutative complex Banach algebra X. Complex Banach algebra X. Algebra of X. Complex Banach algebra of X is said to be self-adjoint is said to be self-adjoint is said to be self-adjoint if the Gelfand map the Gelfand map if the Gelfand map Gelfand map the Gelfand map and symbol means Gelfand map X to C mu function of mu is such that a small x belongs to capital X such that X belongs to capital X means small x belongs to capital X. That implies there exists y belongs to X. There exists small y belongs to capital X such that y equal to X. Such that y equal to X. Where X is the complex conjugate of complex function X cap. Where X is the complex conjugate of complex conjugate of the complex function of the complex function X cap. So using this definition, we'll prove a theorem that is most important for short answer type question. What is theorem? Suppose X is a commutative complex Banach algebra with identity U. X is a commutative complex commutative commutative complex Banach algebra. Complex Banach algebra, complex, Banach algebra, complex Banach algebra, complex Banach algebra, algebra, complex Banach algebra of X, complex Banach algebra with identity E, with identity, identity E. If X is self-adjoint, X is self-adjoint, is self-adjoint, then X cap, X cap equal to, then means, then prove that question formation or show that, prove that or show that, prove that or show that, that is the question formation. X bar equal to X cap such that X belongs to capital X, X belongs to X, is dense in C mu, is dense in C mu, dense in C mu. Proof. Dense in C mu. So X is a subalgebra of, suppose X is a subalgebra, subalgebra, algebra C mu, which separates points of mu, points of mu, separates points of mu, and contains the identity, and contains the identity, identity, conjugate the identity, E cap of C mu, C mu. Further, X cap is closed, further, X cap is closed under conjugation, under conjugation, under conjugation. that is X belongs to, that means small x belongs to capital cap, that equal to, that implies X cap bar also is in X cap, also is in capital X cap. Hence the closure X cap closure so hence the closure is the closure. X bar of X bar is Banach-Kasab algebra. X cap bar of X is also Banach-Kasab algebra. Is also Banach algebra. Banach algebra. Banach algebra. Banach algebra of C mu. Of C mu. And closed under conjugate. Closed under conjugate. Conjugate. Closed under conjugate. Conjugate. F belongs to X, that equal to F bar belongs to X cap bar. Hence by complex Stone-Weierstrass theorem. Hence by complex Stone-Weierstrass theorem. Weierstrass theorem. Weierstrass theorem. TH means theorem of functional analysis. FEA. Follows that X cap bar means Gelfand conjugate equal to C of mu. In other words, X cap, in other words, in other words, in other words, in other words, X bar is dense in C mu. In C mu. C mu. The following theorem gives the condition with Gelfand map. This completes the proof, hence proof. Next, Banach algebra and B star Banach algebra. Banach algebra and B star Banach algebra. Banach algebra. Banach algebra. Banach algebra and B star Banach algebra. And B star Banach algebra. B star algebras. B star Banach algebra. So a complex Banach algebra X. A complex Banach algebra X. Algebra X is said to be Banach star algebra. Banach algebra. Banach algebra. There exists a map. Map star x2 y x2 x2 x x2 x satisfying the following properties. Here image of x is denoted by x star for all x belongs to capital X. Image is denoted by x star for all x belongs to capital X. X belongs to capital X. So first one, x plus y whole star equal to x star plus y star for all x comma y belongs to capital X. Second one, alpha x whole star, that can be written as alpha bar, means conjugate of alpha x star for all x belongs to capital X, alpha belongs to field, means real complex or Libra found or found symbol. Libra found symbol. Third point. It is third property. X into y whole star. X into y whole star, that equal to y star into x star. Y star into x star. Fourth condition. X star whole star equal to x. Fifth one. Star is the involution of x. X star is called the adjoint of x. X equal to x star, we check that. Next. Next definition. Null definition. Next definition. Suppose X and Y are Banach algebras. SB means suppose X and Y are Banach algebras. Banach algebras. Banach algebras. Then map. Then map. Then map. Fx to Y. Fx to Y. Fx to Y is said to be is said to be said to be said to be star isomorphism of F. Yeah, isomorphism of F. Isomorphism of F. Isomorphism of F. Isomorphism of F is an isomorphism preserves involution. Is an isomorphism isomorphism preserves involution, that is involution that is F of X star that equal to F of X star F of X whole star involution. Then prove that is here. Question formation is prove that or show that. So for all small x belongs to capital X. Proof. Definition. One more definition. One more definition. A Banach star algebra X is said to be a Banach star algebra a Banach star algebra X is said to be a X is said to be a B star algebra means Banach star algebra. Banach star algebra. If norm X star X equal to norm X whole square for all X in capital X. Okay. Short answer type question. Short answer type question. So one more definition. 17.0. 17.4.5. 2 mark for short answer type questions. Definition. 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 Suppose X is a Banach star algebra. Suppose X is a Banach star algebra. Banach star algebra. X belongs to capital X. Capital X. Then X star is said to be then X bar is said to be said to be said to be normal if X star X equal to X into X star. X into X star. Then X is commute. X and X star commute. Means commutative property. X and X star commute. X and X star commute. So if X is a commutative, every element of X is normal. We observe that every self-adjoint element is normal. Self-adjoint is normal. A short answer type question on theorem we'll discuss. Suppose X is a B star algebra. Suppose X is a B star algebra. X is a B star algebra. And X is normal element of X. Normal element of X. Normal element of X. Then norm X whole square. Norm X whole square. Norm square Printing mistake here, you need to correct it, right? Norm x square is inside, equal to norm of x whole square. Then here what will come? Prove that or show that. Question formation is like that, right? So now we'll discuss about proof. Discuss about proof. Proof. So write y equal to y star. Right? Y equal to x star into x. X star into x. Then y equal to x into x star by definition. Commute by definition. DEFN means by definition. Commute. So norm y whole square. Norm y whole square can be written as y star into y. Norm y star into y by definition. Right? So that equal to norm 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 x star into x star into x into x star x into x star because they commute norm that equal to norm of x star into x star to x and x star into x star into x that equal to norm x star we are taking x star into x star x star into x norm that equal to norm x star into x star into x star into x. So since x is normal, since x is normal, since x is normal, since x is normal, norm x star whole square that equal to norm x star whole square, x star whole square into x square into x square that equal to norm of x star whole square, norm of x star x square whole star into x square that equal to norm x square whole square by definition. by definition. Right. So hence, 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 norm x square equal to norm y that equal to norm x star x that equal to norm x whole square. So theorem 17.5.1 Omar for long answer type 10 marks question. 10 marks. 10 marks. You do it as homework. Okay, next. Gelfand-Newmark theorem. Theorem. Gelfand-Newmark theorem. Gelfand. Gelfand-Newmark theorem. Newmark. Gelfand-Newmark theorem. Suppose X is a commutative B star algebra statement. Sometimes state and prove Gelfand-Newmark theorem. They will ask like that also. Sometimes they will give the statement. You have to learn before theorem also this for proving this theorem. Suppose X is a commutative B star algebra. Commutative B star algebra. Commutative B star algebra. Commutative B star algebra. Then the Gelfand map. Gelfand map. Map. Gelfand map. X tends to C. Mu is an isometric. Is an isometric. Is an isometric star isomorphism of X. Star isomorphism of X. Star isomorphism of X. On to commutative B star algebra. The commutative B star commutative B star algebra. Commutative B star algebra. C of mu. Proof. Proof. X is a self-adjoint. X is self-adjoint. Self-adjoint by previous theorem. Previous theorem means 17.5.1. Right. Hence, X bar is dense in. Hence, X bar is dense in X bar is dense in C of mu. Since X is commutative, every element of X is normal. Since X is commutative, commutative, every element of X is normal. Element of X is normal. X is normal. Hence, by theorem, hence by theorem, 17.4.7. Follows that follows that Gelfand map X to C of mu is an isomorphism. Is an isomorphism. Is an isomorphism onto C mu. To C mu. C mu. And preserve norms. And preserve norms. Preserve norms. That is, Gelfand is an isometry. Gelfand symbol. Gelfand is an isometry. Gelfand is isometry. Gelfand is isometry. Gelfand is isometry. 17.5.1. That follows that. Follows that. Follows that. Follows that. Gelfand is an isomorphism. An isomorphism. Isomorphism. Gelfand is an isomorphism. This completes the proof of theorem. This completes the proof of theorem. Proof of theorem. The proof of theorem. Completes the proof of theorem. For any compact Hausdorff space, for any compact Hausdorff space, Hausdorff space, Hausdorff space A. Since C of A is a commutative, since C of A is commutative, since C of A is commutative, V star algebra, V star algebra. 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 The essence of Gelfand-Newmark theorem is that the essence of Gelfand-Newmark Gelfand-Newmark theorem is that C of A C of A such that A is such that A is compact Hausdorff space. Hausdorff space. Compact Hausdorff space is the set of all commutative is the set of all commutative set of all commutative B star algebra. B star algebra. Commutative B star algebra within the isometric star isomorphism C of A such that A is the compact Hausdorff space is the set of all commutative B star algebras within isometric. This is the essence within isometric. Within isometric of star isomorphism. Star isomorphism. Star isomorphism. Star isomorphism. Isomorphism. Star isomorphism. This is the essence of C of A star is a compact Hausdorff space. C of A such that A is a compact Hausdorff space is the set of all commutative B star algebra within a isometric star isomorphism. That is the essence of the Gelfand-Newmark theorem. So what we discussed today, we discussed compact. We discussed unit 17 Banach algebras and Gelfand-Newmark theorem. So we discussed the concepts and definition, and Gelfand-Newmark theorem is most important for 10 marks question. Okay. Tomorrow we'll discuss unit 18. Okay. Thank you very much. I'm leaving.